Oof. Okay, sorry. So this is for you, Jake. So pay attention. So area between, it's not for you, it just happened to work out that way. Area between curves and antiderivatives, so you can read this stuff, and basically what we can do is, if we want to find the area between these two functions, we can find the area underneath the first function, f of x, then separately calculate the area under g of x, and subtract one from the other, which will give us the area between. So I'll just scroll down and leave this up for a moment. You can see here's the calculation of the area under f of x for the interval 1 to 3. If you want to see it further, just pause now. And then here's a calculation for the area under g of x. And then ultimately we subtract the area of g of x from f of x and get 28/3 square units. And the question is, what if we subtracted the functions first and then found the area? So let's see what happens in this instance. Could this lead to a shortcut? So f of x minus g of x is 2x squared plus 5 minus 4x plus 1. So it's going to be 2x squared minus 4x plus 4. And let's call it, well, we call that h of x. Let's graph that. So we'll graph simply by just putting in some values. So when x is 0, we're going to get 4. When x is 1, we're going to get 2. Minus 4 is negative 2. Plus 4 is 2. When x is 2, we got 4. That's 8 minus 8. So that's 4 again. Oh, so we got some symmetry. So there's, oh wait, 2 is over here. Okay, and we should go to 3 at least, because we've got to go to 3. So what's this? 3, 9, 18, minus 12 is 6, plus 4 is 10. Okay. And then over here, this will be 10 as well. Okay, and we're looking for the area under this curve. Okay, so we have graphed the function, sketched in the area bit, find the area. So we're going to call it capital H of x. So what is capital H of x? Okay, and every time you do an antiderivative, just take the derivative. That's your check, right? So every time you factor, you FOIL it just to make sure that it's correct. So let's try this. 3 is going to be 2x squared minus 4x plus 4. Okay, we want the area. So area is going to be h of 3 minus h of 1. Right. I guess what we're hoping is that we get the same 9 1/3 square units, right? Because we do this in one step, it's a lot easier than plugging it in twice. So 2/3, 3 cubed, minus 2 times 3 squared, plus 4 times 3, plus c, minus now we got 1, so 2/3, 1 cubed, minus 2 times 1 squared, plus 4 times 1, plus c. Alright, so kind of simplifying where we can, this 3 is going to take that to 3 squared. We're going to get 18. That's 9 minus 18, plus 12, plus c, minus 2/3, that's your plus 2, minus 4, minus c. Okay, so the 18 minus 18, 12 plus 2, so the c and minus c. So that's 14 minus 4 is 10. 10 minus 2/3 is 9 1/3 square units. Did you get the same answer? Well, if you've done enough worksheets at this school, you know that when it says, are they the same? 97.5% of the time, it's yes. So it's the same, right? So we don't have to work out separate areas and then subtract, right? We can just subtract one function from the other. So it turns out, in general, if f of x is greater than or equal to g of x on an interval from a to b, where f prime of x equals f of x and g prime of x equals g of x, then the area between f of x and g of x can be determined by any of the following. Okay? You can read. Mostly we're aiming for this, right? We just want to get f of x minus g of x. Call that h of x. Note, h of x will always be a positive function as long as f of x is greater than or equal to g of x, right? So in other words, as long as f of x is above g of x, you're always going to get a positive function. Okay, and let's just demonstrate that. Use a really simple function to show how this works. Find the area between f of x is negative 2 and g of x is negative 4 for the interval between 0 and 3. Okay, what's that area? 2 by 3, right? So like, area is equal to base times height. So area is 3 times 2, which is 6 square units. Now create a new function where h of x equals f of x minus g of x. So h of x will equal negative 2 minus negative 4, which is negative 2 plus 4, which is 2. And draw that and find the area on the interval. So here's the new function here. And we want that area, which is also 6, right? Yeah, so area is base times height. Area is 3 times 2, which is 6 units squared. So as you can see, if f of x is greater than or equal to g of x, then h of x will always be a positive function, and the area under h of x will be the same as the area between f of x and g of x, right? Okay, that works. So now let's apply that. Find the area between f of x equals 2x and the x-axis for the interval negative 2 to 2. Well, it depends on your concept of area. So the question, would determining f of 2 minus f of negative 2 work? Okay, let's try that. So what's capital F of x? So capital F of x, the antiderivative is just x squared plus c. So f of 2 minus f of negative 2 will be, okay, so 2 squared plus c minus negative 2 quantity squared plus c. So that's 4 plus c minus 4 minus c, which is 0. So that won't work. Why does that not work? So we have an area that's underneath. We have two areas here, right? We have one area which is above the x-axis and below the function 2x. But the other area we have, so that's this area. The other area we have is below the x-axis and above 2x. So this here, this is the upper, and this is the lower. And here, this one is the upper. And this function here is the lower. Okay, so if we were going to do this, what we would have to do is say, so for the interval 0 to 2, so in the interval 0 to 2, we're going to say that the upper function minus the lower, so let's call that h of x, is equal to f of x minus g of x. Okay, so here, the x-axis, so we'll say this function, the x-axis is g of x is equal to 0, right? I mean, the x-axis has an equation, y equals 0. So we'll call it g of x. So here, this will be 2x minus 0, h of x. So then capital H of x is equal to x squared plus c. Get bonus. Okay, let's just close that window. Okay. Yeah, I don't use it. But. So then this area will be h of 2 minus h of 0, which will be 2 squared plus c minus 0 squared plus c, which is just going to be 4. And on the interval, whoops, square bracket, negative 2 to 0, then let's call it k of x. K of x will be g of x, that's the upper function, minus f of x. Right? So this time the x-axis is on top, right? It's above the function 2x. So k of x will be 0 minus 2x. So k of x is negative 2x. Capital K of x will be negative x squared plus c. And then our area is equal to k of the upper k of 0 minus k of negative 2. So it's negative 0 squared plus c minus negative the negative of negative 2 quantity squared plus c. So this one here is, this just is c. Minus, okay, so that's 4, that's negative 4, minus negative 4 becomes plus 4, minus c. That area is 4, 4 plus 4 is 8, right? So we have to calculate this, unless we want to end up with a negative area, right? So if we just use it the way it says, go through this interval, but the upper function changes, right? So we actually have to then split the interval into 2 parts, right? And say which one is the upper function, which one is the lower function. Take upper minus lower, then use that to generate the area in that interval. So we might have to add a couple of areas together.
Which one was the upper function in this case?
Okay, so from 0 to 2, the upper function is 2x. Okay, because it's above the axis. From negative 2 to 0, the upper function is the x-axis. Right, because it's above. And the x-axis has an equation y equals 0, right? So I just call that g of x equals 0. Okay, so we have to subtract, right? It's always upper minus lower if you want to get area. Because area is a positive quantity, right? It's like so many square units. So, all right, 3 more. Okay, you got to change your sheet. We decided to change the boundaries on this, make it a little bit easier.
Didn't we have to add those up to get the final answer?
Yeah. Oh, sorry. Did I not throw down the 8? Come on. There we go. So 8 units squared, right? Which is what we knew the area was if we just looked at the thing and figured out the area, right? Because we would say, well, 1/2 base height, right? 1/2 of 2 times 4 is 1 times 4. 1/2 base height, also another 4. Okay. So the area should be 8, right? And it is. Determine the area between y equals sine x and y equals cos x. So you change your sheet. Your sheet I think says 0 to pi over 2. Change it to pi over 4 to 5 pi over 4. All right. We decided to make this one a little bit easier. You might think, wait a second, I mean 0 to pi over 2 seems... So let's sketch out what we have here. So let's draw a sine. So I got to go to 5 pi over 4. So here, let's call this pi over 2, pi, 3 pi over 2, 2 pi. Okay, so sine function, let's call that 1. Negative 1, so sine is going to be this, 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 and this. Okay, so that's y equals sine x. And here, do the cosine in red. So cos is this, 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 this. Okay, so sine is sine and cos is cos, but they do actually meet. So where do sine and cos meet? What's this point here? When is sine theta equal to cos theta? Pi over 4. Pi over 4. And then they're equal again here. What is this one? Pi over 4. Okay. So we're finding the area. So what's going to make this easy, or easier, is that sine is always above cosine in the interval pi over 4 to 5 pi over 4. Right? So we don't have to worry about, we got to split it into two intervals. If you did 0 to pi over 2, you would have to do the interval from 0 to pi over 4, because sine would be above, or sorry, cosine would be above, and then you'd have to go from pi over 4 to pi over 2 and do two separate areas, right? In this case, we don't have to. Okay, so we can say, so let's call this f of x. Let's call this g of x. So h of x is equal to f of x minus g of x. Is, right, and remember, it's upper minus lower, so sine x minus cos x. Sorry, that's little h of x. Little h of x. Capital H of x. All right, use your anti-deriving skills. Anti-deriving. Use your, figure out the antiderivative. It's pretty straightforward, but, you know, there's a little bit of a... Alright, how we do? Minus cos x minus sine x? So the derivative of cosine is minus sine, right? But I want positive sine. So if I just put cosine there, I'm going to get minus sine. So I'm going to put a minus sign in front of the minus. You get the idea, right? And the derivative of sine is cos, so we just put a minus sine x. Alright, so the area we want then, area will be h of 5 pi over 4 minus h of pi over 4. So let's go and substitute. So it's equal to the cos of 5 pi over 4. No, sorry. It's equal to the negative cos of 5 pi over 4 minus the sine of 5 pi over 4. Right. I did. Plus c. Minus the negative cos of pi over 4 minus the sine of pi over 4 plus c. Okay, so fill in the next line, just put in the value for this, the value for this, the value for this, and those values. So just write it out, putting in the values and removing the brackets, right? Which means you're going to flip signs and stuff like that. So that's plus okay, so everything's root 2 over 2. And everything's all positive. Right? When you take into account you're subtracting negatives and the first bunch is the negative. So the 5 pi over 4 is a negative root 2 over 2. So this becomes positive, this becomes positive. So we have 4 root 2 over 2's, which is 2 root 2's. Square units. All right, now we're going to kick it up a notch. Determine the area between y equals x plus 1, x minus 2, x minus 3, and y equals negative 2x plus 6. And we're going to be nice and give you that x plus 1 times x minus 2 times x minus 3 is x cubed minus 4x squared plus x plus 6. To save you those 23 seconds that it would have taken to multiply it out. So how are we going to start this? What should we do? Before we do anything else, what should we do first? So we need to know who's on top, right? Which is the upper function. Which means we need to draw a picture. And we need to set these equations equal to each other and solve for their intersection or intersections. Right? So if we start out, let's just kind of draw this. Maybe below this, we'll just start off. So when is x cubed minus 4x squared plus x plus 6 equal? So in other words, I know the zeros for this guy, right? I mean, it's negative 1, positive 2, positive 3. I know it's a cubic, so I know it, it's a positive cubic, so it's doing this. And I've got its zeros. Okay, well, let's figure out where they meet, just so we can decide how do we want to scale the whole diagram. And we know negative 2x plus 6 falls to the right with a slope of 2 and has a y-intercept of 6. But where do they meet? Let's try this. So we got x cubed minus 4x squared plus 3x is equal to 0. So 6's go away. We can factor an x out of that. And that gives me x squared minus 4x plus 3. So this would be x minus 3x minus 1. So 0, 3, and 1. So these two curves are going to intersect at 0, 3, and 1. Actually, no, let's write it out like this way. So x equals 0, x equals 3, x equals 1. When x is 0, y is equal to. So if they intersect, just go into this guy, right? It's going to be easier to work out the y values from the negative 2x. I mean, they're equal, but why not stick it in there? So 0, 6. So we've got the point 0, 6. When x is 3, it'll be 3, 0. And when x is 1, it'll be 1, 4. Okay, so we got 0, 6, 3, 0, and 1, 4. Okay, so let's scale this out. 2, 4, 6. We know we have a y-intercept. The y-intercept of this is 6, and the y-intercept of this is 6. Oh, and we know that because we got 0, 6. Negative 1, 1, 2, 3. So negative 1, there's a 0. Positive 2, positive 3. We've got intersections at 0, 6. So we'll do that. Red, 0, 6. What were the other ones? 3, 0, and 1, 4. Okay, so 3, 0.
Which equation did you put in x?
It doesn't matter. Because they're equal. But I stuck them in this because it's easier. Okay. I mean, you could. So you put a 0, well, either way. You put a 0 in either one, you get the 6. You put a 1 in, it's a lot easier. They're going to work out the same. Okay, so that means, well, 2x minus 6 is this line here, right? So that's y is equal to negative 2x plus 6. And then the other line is going to do what? The cubic. I guess it's going to be red as well. There's the cubic. So looks like the cubic's going to be above. Oh, what do we say? There was one other point, right? 1, 4. 1, 4. So the cubic is above. So if I want the area between these two curves, I've got two areas to work out. And in one of those areas, the cubic is above. And for the other area, the straight line is above. Okay, so let's do this. So let's say from 0 to 1. On the interval from 0 to 1, which is where they first meet at 0, 6, the upper function, so we're going to say f1. This time I'm going to call it f sub 1. So we'll just do f sub 1 and f sub 2. Okay, we stay with the f's. The upper function is the cubic, so it's x cubed minus 4x squared plus x plus 6 minus negative 2x plus 6. Okay, so just simplify that. What do we got? X cubed minus 4x squared. That's going to add plus 3x. Plus 3x. Done. Okay, so that's f1 of x. So, all right, while we're here, let's do capital F1. Okay, let's find the antiderivative, right? We're going to use to calculate. So all of this is going to be for the area between 0 and 1, where the cubic has the upper hand. So 1/4 minus 4/3 plus 3/2. And then on the interval from 1 to 4. No, not 1 to 4. Sorry, from 1 to 3. 1 to 3, yeah. The point was 1, 4. The interval is 1, 3. So let's call that little f2. And in this case, the linear is up top. And you notice how you have a whole page to do this question? Because unless your name is Kendra, you need a whole page to do this question, right? It's going to fill the page. So what do we got? Negative x cubed plus 4x squared minus 2x minus x minus 3x 6 minus 6 plus, just it, that's it. So that's f2, little f2. Now you notice f1, little f1 and little f2 are the same, except the signs are opposite, right? Because one's on top of the other. So doing the antiderivative is not a big deal. As long as you do this one right, you're just going to put opposite signs. So negative 1/4 x to the 4th plus 4/3 x cubed minus 3/2 x squared plus c. All right, so what's our area? So the area is equal to little f1 of 1 minus, capital F1. So the area is the area from 0 to 1. So f1 of 1 minus f2 of 0 plus the area from 1 to 3, which is f2. So f2 of 3 minus f2 of 1. Yeah, f1. It's Formula 1. Insert. Yeah, we'll extend this f so they kind of match up. All right, just plug it in. So it's not hard. It is extraordinarily tedious, but it's not hard, right? So leave lots of room, okay? So just fill it in, right? So F1 is 1/4. So I'm going to put down the first set of square brackets. 1/4 of 1 to the power of 4 minus 4/3 1 cubed plus 3/2 1 squared plus c. Okay. Minus 1/4 of 0 to the 4th minus 4/3 0 cubed plus 3/2 0 squared plus c plus. Okay. I'm going to go down to the next line. You should be able to get it across the page. I used to get a lot thinner line out of the whiteboard. This new version of Smart Notebook, I can't get as thin a line. So plus minus 1/4 of 3 to the 4th plus 4/3 of 3 cubed minus 3/2 of 3 squared plus c. Okay, wait, that's just the first one. Got a set of brackets there. Oh, I did. Minus, okay, and then we do minus 1/4, 1 to the 4th, plus 4/3, 1 cubed, minus 3/2 of 1 squared, plus c, square bracket. So, next line, I would probably leave the square brackets in place and just work out. I mean, this one's trivial, right? Because it's 1s and 0s. So that's equal to, so we just go into here. So let's do the square brackets. So I've got 1/4 minus 4/3 plus 3/2 plus c minus 0 plus 0 minus 0 minus c plus, okay, so 3 to the 4th, 81, so minus 81/4 plus, that 3 is going to take out that, so that'll be a 36. 9 27/2 minus 27/2 plus c minus negative 1/4, so plus 1/4 minus 4/3 plus 3/2 minus c. All right, let's just take what we got there, just writing down the numbers this time. Yes. Sorry. Oh, okay. There. More about where I want it to be. I think I have the edge of the recording too close to the edge of it. Oh, perfect. Okay. 1/4 minus 4/3 plus 3/2. I'm not going to write the c's down. Minus 81/4 plus 36 minus 27/2. If I can write the c's down. Plus 1/4 minus 4/3 plus 3/2. All right. Let's deal with the halves. And we'll deal with the have-not-haves. Not the have-nots. The not. Okay, 3/2 plus 3/2 is 6/2, which is 3. So that's 3. That's just a number. So then we got a 36. Well, 3 is just a number, right? Or we could do 6/2 minus 27/2 and get negative 20. Well, wait. So 1/4 plus 1/4 is 1/2. Okay, so if we take 1/2 away from 27/2, or sorry, add 1/2, we'll have negative 26/2, right? Which is negative 13. So I'm going to go with a negative 13. 3 halves plus 3 halves is 3, so I'm going to go with the plus 3. So right now I've taken the quarter, this guy, and this guy. Okay? So we've dealt with all of them. We now have negative 13 plus 3. Then we've got minus 8 thirds, minus 81 quarters, plus 36. Okay, so let's take our numbers. What's that? 39 minus 13 is going to be 26. Minus, okay, to add these we're going to have to go to twelfths, right? So minus 32 twelfths, minus 243 twelfths. No, you can use calculus.
Are you gonna actually read what these numbers on the test?
Yeah, this, you could get one that looks like this. Okay, hang on. I'm going to pause and move the boundary. Okay, what do we got? Minus... Okay, so what's this add up to? 32 plus 243. 275 over 12. Okay, so what's 26 times 12? 52 and 26. 312. So 312 minus 275 all over 12 to be 37 twelfths. Or 3 and 1/12. Okay, so there, I'll leave that up. But does he know he's stupid?
What about potatoes?
What?
Slovak studies. And beef. That is nice.
Okay, done.
Done. No,
Done.
example 5.
Example 5. Get on a separate piece of paper. On a separate piece of paper, because you're going to need one full sheet. And we were not about to photocopy a blank page for you, so. Determine the area bounded, enclosed by y equals x squared minus 4, y equals 3x, and y equals 6 minus 3x. Okay, what's the starting point? Get a piece of paper, yeah, that's number 1.
So low down.
Gotta get the paper. No, what they're making salami on Thursday. I might make some more jerky on the weekend. I'll just try and not
Can you please
crisp
bring
it.
some? I'll be your jerky connoisseur.
This will not be crispy turkey.
No, I will be the jerky connoisseur.
I will aim for... Yeah, this could poison you because it didn't quite get to the temperature they say, but it's got curing salt in there. That should kill off
You're at
the...
least not getting cancer.
Yeah, exactly.
What's worse?
What do you want to die from? Okay, we know what x squared minus 4, we know what all these lines look like, right? So we could graph them out, but before we graph them, let's see where they meet, which will help us set a scale, right? So we want a sense of scale here before we draw this out to get an idea where do all these lines meet. So we have to do 3 pairs, got to solve 3 pairs of equations, right? X squared minus 4 equals 3x, x squared minus 4 is 6x minus 3, and 3x is 6 minus 3x. Okay, so go ahead, solve those 3 sets of equations, and I'll pause. Okay. Good timing. So here's all 3 equations solved. X squared minus 4 is equal to 3x, gives us x equals 4 and x equals negative 1. Seeing as these are equal, I'm just going to plug it into the 3x, get the point. 412 is the point of intersection of these two, as is negative 1, negative 3. X squared minus 4 equals 6 minus 3x, the other intersection of a straight line with the quadratic, and they intersect at negative 5, 21, and 2, 0. And lastly, the 2 straight lines intersect at point 1, 3. So if I'm going to draw this, I'm going to need to extend from negative 5 to positive 4 on the x-axis, and we're going to have to go from -3 to positive 21 on the y-axis. Okay, that gives us an idea if we want to get a reasonably scaled drawing, something that's reasonably representative. So let's do this. So let's throw down a grid. We don't have to go that low on this, right? We have to go to -3, I think. Okay, so 3, 6, 9. Yeah. Okay, so 3, 6, 9, 12, 15, 18, 21. And we need to go from -5 to positive 4, so 4. -5. So let's put down a point. So in red, I'll just do the intersection point. So -5, 21. 2, 0. 1, -3. Sorry, -1, -3. -4, 12. 2, 0. Got that. And what was the last one? 1, 3. 1, 3. Okay, so the x squared minus 4 goes through this point here and this point here. So, and it's gonna, okay, x squared minus 4 is gonna bottom out here. It's gonna look like that. And then it goes through 2, 0 as well as 4, 12. Okay, so there's the x squared minus 4. Next one is y equals 3x. Okay, so that's pretty easy. It goes through 1, 3, and 3x goes through this one here. And it goes through 4, 12. Y equals 4x. Well, we could give you a grid. Y equals x squared minus 4. And the other straight line we have is 6 minus 3x. So that's going to go through these guys, right? So it's go through 6, and it's going to go through the 2, 0. And, oh, it goes through -5, 21 as well. Okay, so it goes through that. Okay. 6 minus 3x. Okay, so we need to figure out which the upper curve is and when it's the upper curve. And so 6 minus 3x here is the upper curve from -5 to where? To 1. So on the interval -5 to 1,
What's your underline?
so from -5 to 1, the upper is y equals 6 minus 3x, and the lower is x squared minus 4.
But isn't the lower 3x from -3 to 1?
We're not, okay, so what we're finding is,
Can you just do little scribbles?
okay, so we have two areas. We have an area this area here, right? So we have the area where this is the upper function, which is going to go to here. Okay? So from -5 to +1, the upper function is this 6 minus 3x. So it's the green area here. From 1 to 4, the upper function is 3x. So it will be the yellow area here. Okay, so we have two regions to deal with, right? So we want the region bounded by these three curves. Okay, this straight line, and the quadratic. The quadratic is always the lower function here, right? It's always at the bottom. From -5 to 1, y equals 6 minus 3x is your upper function, right? But from 1 to 4, it then changes, right? Now it's just y equals 3x. So we have to work out two areas. We're going to have to add them together. Right, so we've got the area from -5 to 1. So let's do this as f1 of x is equal to upper minus lower and so on. So, okay, welcome back. So using little f1 for upper minus lower, getting a simplified expression, and then finding the antiderivative, capital F1 for the green region here. And then for the yellow region from 1 to 4, using little f2, upper function is 3x here. Lower function gives us negative x squared plus 3x plus 4. And again, the antiderivative. Now you just get to plug it in and work it out. So the area there, spoiler alert, there's the answer. I'm not giving you the intermediate stuff. That you can do. If you get 67.5, say hallelujah. Oh, I mean, what do you got? 4, you're putting in -5s, you got 125s, you got 25s, you got 64s, you got 16s. Yeah.
I'm just gonna write the answer at the bottom.
Yeah, right answer at the bottom. I mean, it might take more than 10 minutes to do all of that. Okay, but I'm going to end the recording here, and just that's your answer. And you can check on Schoology for the actual. Oh no, you can't because maybe.
Can you just
I'll fine. You know what? I'm going to go to
just
another
go to the
page.
picture and then scan your answer on it and put it on.
No, I'll just do. I'll do the rest of it and pop back here. So I will put, for those of you watching the video, I'm gonna now work this out. Or actually copy it down off my page. So if you're putting in x is 1 or x is 0, don't bother putting in the 1. I mean, you can just, we'll let you evaluate 1s and 0s on the fly. So like -1/3 minus 3/2 plus 10 plus c. That's the first one, right? Minus. But if they're -5s, then you gotta put them in. Just. Good, I just dragged the frame. Alright, re-drag the frame. Equals.
less driver.
Oh.
Less missed years, less.
Yeah, yeah. There's shifts. It's always embarrassing on that.
Yo, you're switching to second gear and all of a sudden.
Yeah, or grind. You grind and you're just like, oh, I can smell my clutch. It's burning.
They're gonna do some of the next tests.
It burns. It burns.
He's not gonna let you drive his car.
I think it's fairly safe to make the bet, though.
Like, if
Yeah. Yeah. Well, nobody knows who anybody is. Okay, now they know. Huh. And I have an incentive to make it impossible to get 100%.
No, you made this stuff each way. You can ask those rules.
Okay, and now that's done.